All right, video lecture 1.2a is first half of video lecture 1.2. We'll be discussing the branches of chemistry. Last lecture we alluded to the fact that the chemistry is a physical science, and we also kind of hinted that there are many subcategories or branches of chemistry. We're going to focus on those in this video lecture. The first type of chemistry I want to mention is called organic chemistry, and when we think of the term organic, a lot of us think of natural. We think of organic vegetables as naturally grown vegetables, um, and that's not a bad way to look at this, but when we think of natural, we think of nature, and we should think of living things, and all living things are made of carbon. Now, organic chemistry doesn't study living things. We'll get to that type of chemistry in the next slide. But organic chemistry does deal with things that were once living. And so anything that was living or once living is made up of carbon, more specifically carbon-hydrogen bonds. So when we deal with fossil fuels, they're made from ancient plants and animals. And so those are organic substances, and that makes the fuel itself organic. Also, any medicine you take is made from organic substances, and also alcohols and fibers are included in that as well. And so organic, the key thing is the carbon-hydrogen bond that we're focused on. Organic chemistry is very closely related to anything in the medical field. So if you're considering any type of medical route with your college or with your career, you will definitely be involved in organic chemistry. We won't focus on that much in our class, um, but it is a very important area of chemistry, and it's a very big area of chemistry. What we'll focus on most in our class, though, is inorganic chemistry, and inorganic chemistry is everything else. Here in the definition it says non-carbon compounds, but that's not entirely true. It's just the non-organic compounds. And so there are some compounds that have carbon in them that we will talk about, and of course we'll talk about the element carbon. But most of what this focuses on are acids and bases, minerals, metals and nonmetals, and the semiconductors, which are kind of in between metals and nonmetals. And we'll talk about that a lot later, but inorganic chemistry is even more broad than organic. It's kind of everything else. But within even inorganic chemistry, we can break that down further. But remember, organic chemistry has to do with medicine, so you could think of organic chemistry as for your health. All right, so other branches of chemistry, we have something called analytical chemistry. Um, and this is very detailed chemistry. This is when we want to look at a detailed analysis of a substance or a material. Sometimes we might be looking at it qualitatively or quantitatively, which means we might want to look at number-based analysis, or we might want to look on quality-based analysis. All that really means is that we're analyzing this substance. Food labels and food nutrients is a great example of this. When scientists or chemists go through and they determine how many calories and grams of fat and grams of carbohydrates are in a substance, those numbers they have to have that they put on the food label have to be very close to being accurate. If you're counting your calories like some of you do, and it says 100 calories, if there's actually 150 in there, that throws off your diet plan quite a bit. And so these numbers are based on repeat measurements and, again, deep repeated statistical analysis, and this has a lot to do with data and a lot to do with repeat experiments and measurements. So if you like statistics, you would like analytical chemistry. Something we foreshadowed a little earlier was called biochemistry, and this is where we're involving the living things now. This is exactly what it sounds like. It's combining biology and chemistry together. So we look at biological processes like photosynthesis. There's a chemical reaction that takes place through photosynthesis where the plant takes carbon dioxide and chemically changes it into a carbohydrate. And for using that for its food, and that's a chemical reaction within a biological system. Also, the metabolism of proteins and fats and carbohydrates in your body is a chemical process as well that we can describe chemically in addition to biologically. So biochemistry is a combination of those. Another very popular and ever-growing field of chemistry or branch of chemistry is environmental chemistry. This is focusing on environmental processes. Of course, pollution is a great example of that, with air or water pollution, or even ground pollution. But also farming has a big impact on this, especially within our community. Farming uses a lot of products, a lot of chemicals within fertilizer and pesticides and herbicides on crops. Environmental chemists really do a lot of experiments based on that so as not to wreck the environment but still help the farmer produce good crops with hopefully with the rain that might come with that. So environmental chemistry is a good branch of chemistry for farmers in our area, but also ever growing field just with the risk and problem of pollution within our culture. The last two branches of chemistry we're going to talk about. The first is industrial chemistry. This is the study of chemical processes in industry. We have a lot of industry around us. In Great Bend, there is a company called Fuller Brush that deals with cleaning products and plastics. And so anything that involves something industry-based would be considered industrial chemistry. Of course, this can definitely overlap into some organic chemistry as well, but ultimately it has to do with industry. And the last type of chemistry we want to mention is called physical chemistry. And this, kind of like biochemistry, involves two topics. This involves physics and chemistry. And when we talk about physics, we're dealing a lot with motion and forces, and definitely motion is provoked by energy. And so the most common form of energy, hopefully you can imagine, is heat. And that heat changes chemical reactions. Heat might instigate it, or it might speed it up. And it definitely moves atoms. And atoms are chemistry, and so the way heat interacts and causes motion in chemical reactions is a fancy way of describing the study of thermodynamics. And so physical chemistry is pretty challenging because you're involved physics, which is a heavy math related subject, and the chemical reactions that intermingle with that physics. So it's a very challenging branch. But these are the main branches of chemistry, and we'll get into the scientific method in the next section.